Hi, my name's Gareth. About 6 months ago we installed solar panels and earlier on this summer we also installed a battery at home to store some of the energy. This has had a very significant effect on our energy bills. I've been speaking to a few people recently about what's happened because they're considering buying solar or battery, and so I thought I'd put together this short video to explain in a bit more detail what's happened to our electricity costs over the last 2 years and why. So let's take a look at what actually happened to the bill. We started off in August 21, paying about £50 a month. This went all the way up in December 22 to well over £250 a month, and now we're most of the way back down, so we're paying about £60–70 a month. So what's happened on this journey? Well, significantly in September 21 we got an electric car. So our electricity use went up as a consequence of that, but we also switched to a tariff called Octopus Go from Octopus. This gave us a 4-hour window in the evening, which meant that our electricity was super cheap, and that was when we charged the car. And that was brilliant. Even halfway through this period, we had the Ukraine war started and energy prices went through the roof. But for the first 6 months or so, we were protected from that because we had this fixed term contract until we weren't. So in September 22, we had to switch to a new tariff, and so we went with one called Intelligent Octopus. This again gave us a evening periods where electricity was cheap, but the whole thing was a lot more expensive than it was previously, and you can see how much our monthly bill went up from September 22 onwards. But a little bit later on, in the spring of this year, we installed solar panels, and you can see that this started having the effect of bringing the bill down. So it was bringing the bill down because we were generating some of the electricity that we were using at home from the solar panels. And then this final period, the bill started to really plunge from June this year onwards. And they really plunged because that was the point where we installed the battery. So let's take a look at what happened to the unit cost of electricity over this period. So what I've done here to draw this graph is essentially I've taken the total amount we've spent on electricity in a month, and we've divided by the total amount of energy that we've consumed. So this kind of takes into account the fact that some of that energy is generated in later periods by solar, and it gives us an amount per unit, so pounds per unit that we spent on electricity. So even if our consumption varied from month to month, this is like showing the underlying price of a litre of petrol. The other thing that I've shown on this graph is the red line. The red line is what the British government price cap has been for energy over this period, okay? And for most people, this has been like standard variable rate. It's been what most people have paid per unit for their electricity over this period. So you can see that although that energy, that red line has gone up and has sort of come back down a bit, the variation in what we've paid at home has been way bigger. It's been way bigger. So let me just kind of go back to those milestones again. So we start off in September 21 with the new electric car and going on to this new Octopus Go tariff. So in a bit more detail, we're paying 5p a unit between 8:30 and midnight 30, and we're paying 15p a unit for the rest of the time. That off-peak window, that 8:30 to midnight 30, was pretty nice, because although you've probably cooked dinner by that point, there's still quite a lot of domestic consumption can take place. So your dishwasher, tumble dryer, washing machine, that kind of stuff can be well used in that evening window, and we used it a lot to save some money. So about halfway through our period on Octopus Go, Russia invades Ukraine. Immediately the wholesale prices for electricity start going through the roof, or the wholesale prices for gas, I suppose, start going through the roof, which pushes the electricity price up. The price cap amount goes up significantly at that point, and it goes up again. But that first rise doesn't affect us because we're on this fixed term contract. Then look what happens to the unit cost of electricity once we have to switch from Octopus Go to Intelligent Octopus. So everything has gone up quite a lot here. So our off-peak electricity cost has gone from 5p to 7.5p, so that's a 50% increase. Our on-peak electricity has gone from 15p to 40p, so that's nearly 3 times as much. And you can see what effect that's had on this unit cost. This blue line is kind of shot right up, and that's pushed the bill right up. So this kind of carried on as it was until the spring of this year. In the spring of this year, we installed the solar panels. We start generating electricity. This is beneficial for two reasons. One is obviously every unit that you generate and can use is one that you don't have to buy. But also the timing. So these solar generated units are turning up in the middle of the daytime. That's the on-peak time for electricity. So we're actually saving 40p at this point for every unit of solar that we generate, or rather every unit that we generate and can store, because some of it we have to export because we don't have a battery. So we're starting to see that having an effect on the unit price, and the unit price is coming down at this point. And then the unit price falls through the floor when we put the battery in. Is because everything that we are now buying from this point on is either cheap, 7.5p unit, or free, generated by the sunlight. Okay, so there's no 40p units being used at all at home. And you can see that by taking a look at this graph. This is our consumption from yesterday, and this is very typical. So at the start of the day, we've got quite a lot of electricity being used in the first hour, because we are charging the domestic battery and we're charging the car battery. But the domestic battery gets full by about 1 o'clock in the morning. So the rest of that off-peak period is charging the car. That's done by about 4 o'clock in the morning, and then from 4 to 5:30 we can see we're still pulling from the grid a little bit, because why not? But that use is way low, and it stops dead at 5:30. So we are effectively off grid from 5:30 in the morning onwards, and that's why the electricity is so cheap. So let's see how this all comes together to reduce the amount that we're spending on electricity. So what I've done in this graph is try to separate out where the different costs are coming from and where the different savings are coming from. So the first thing you need to understand is we all have to pay a standing charge every day to connect to the grid. It doesn't matter if we're importing or exporting. If we're on grid, we're paying a standing charge, and that's in common, sort of more or less whatever tariff we are on. So if we take a look at this graph down the bottom here, we've got this thin slice of dotted area, and that shows us the effect of the standing charge. Next up, I wanted to show in this very pale blue strip that is next the bottom of the columns how much it costs to charge the car. And I wanted to show that there because really for most of this period, this very pale blue stripe is not very big in proportion to the cost of the rest of the electricity that we're consuming. So I was trying to show that even though we have got an electric car, it's not really dominating the costs until we get to this most recent period over on the right hand side of the graph, where the amount that we're paying for the car electricity is actually sort of quite a large portion of the total, and that's because everything else is so damn cheap. Okay, so next up on this graph is we've got this bigger wedge of slightly darker blue. Now that column there, the sort of sum of everything up to there, the standing charge, the car charging cost, and then that sort of slightly darker blue bit, that's the total that we've actually spent on electricity. So the shape of that graph corresponds to that first graph that I showed you. All right, so this is what we're actually spending on electricity. And where are the savings coming from? Well, the first bit I wanted to highlight is the red bit. Now the red bit is how much all of this electricity would have cost if we'd bought it from the grid at the price cap amount. So that's the kind of, the average amount for electricity that people in the UK will have been paying. So that's what this red sort of area is up here. So you can see there is quite a big saving that's coming in just because we've got an EV. Because we've got an EV, we can get access to these tariffs where it's cheaper in the evening than it is in the daytime, and so there's quite a big chunk of saving is just coming from there. But then let's hop over to March of 2023 and see the effect of this yellow. So what this yellow represents is the savings that are coming from having solar and then the battery. For the first 3 months here, there is a reasonable saving kicking in, and that's just the solar electricity taking effect. But you can see from June onwards there's a much bigger saving. So all of this yellow chunk here is the saving that's come about as a consequence of having put in the battery. Because with the battery in place, we can now buy all of our electricity either for 7.5p overnight, or we're getting it for free because we're generating it locally. Well, we can take a look at the actuals. This is the amounts that we've saved each month since doing this work. And the average saving across this period, before we got the battery put in, was about £78. Okay, so we're saving about £78 a month from the contribution from the solar electricity. And then when the battery went in, so from June onwards, the average saving has been about £170 a month. Okay, so that's battery plus solar. Now the cost of all of this was £11,500. So if we're trying to work out how long it's going to take for us to get our money back, we basically take the amount that we're saving per month and divide that into the amount that we spend. And that should tell us how many months or how many years to recover the cost through the savings. So we do that calculation, the time to recover the cost. If it's on the basis of the pre-battery savings, so just from solar, it would take about 12.5 years. Once the battery's kicked in, that ROI time has come all the way down to just over 5.5 years, which is pretty nice. Now, the batteries themselves have got a 10-year life. I hope that they will carry on working after that point, but their performance will degrade and they're only guaranteed for 10 years. So what do the savings look like over a 10-year period? Well, the raw savings themselves on these figures are around £20,400. But the kit has cost us £11,500 to install. So what that means is that the net amount that we've saved is about £8,900, about £9,000 per over the 10-year period. So that's about £900 a year saving. Now, we're not doing this just to save money. We're doing this because we want to help reduce the carbon footprint of the consumption that we're making, and that's going to come a lot from solar power, and it's going to come a lot from the fact that we can, in theory, we can pull from the grid into our battery at cleaner periods. Now, whether or not that actually corresponds to the cheap periods is not so clear, and that's something that I hope to come back to on a future video. But for now, I hope this has been helpful for you to see some actual real data, some real consumption figures and cost figures. I'm not saying that these are average or that these are going to reflect what will happen to you. You might get bigger savings, you might get smaller savings, I don't know, but they are real, truthful, honest actuals, which might help you to think about roughly what kind of savings you might get if you choose to go down the route of installing a battery and solar at home. My name's Gareth, and I will look forward to seeing you on the next video.